Alright, so here's a video covering common factors and common multiples. We are going to start here on page 39. And we kind of started the day talking about factor pairs. And it could be a review. Factor pairs basically split up the number. What two numbers, when multiplied together, give you that number. So I like writing the number like this and then underlining it. And then I think of all the numbers I can to multiply together to give me 42. So I usually just start with 1. 1 times that number, in this case 42, will give me 42. And then we go from there. 2 times 21, 3 times 14, 6 times 7. Now I could continue on, but then it would start repeating. I'd have 7 times 6. So those are all the pairs of factors. And then we did it with 56. Again, 1 times 56, 2 times 28, 4 times 14, 7 times 8, and so on. All right. Now, I call that method the horseshoe method, simply because you can then draw a horseshoe-shaped arrow around, which is going to help you later because you need to list all factors. But before we do that, just to review, if 16 is my number, I'm going to do 1 times 16, 2 times 8, 4 times 4. And again, I stop there because if I continue on, it's just going to be a repeat of my pairs of factors. All right, now listing all factors. Notice what I do. When I put the arrow here up on 1 and I go around, it puts them in order from least to greatest. Then I can list them 1, 2, 4, 8, and 16. And notice I only listed the 4 one time because we only need one of the 4s there. All right, so that is listing all the factors. So there's a difference between factor pairs and listing all the factors. List uses commas. Factor pairs uses the multiplication in between the numbers. All right, then we talked about common factors. So what do these two numbers have in common? We looked at 12 and 15. So first step, find the factor pairs, 1 and 12, 2 and 6, 3 and 4 for 12. For 15, it's 1 and 15, 3 and 5. And then I do the horseshoe, and I list them out. 1, 2, 3, 4, 6, and 12. And then I list them out for 15. 1, 3, 5, and 15. 1, 3, 5, and 15. Okay? And then it asks, after I list all the factors for 12 and for 15, here's my lists, I list the common factors. So a good idea is to go up and circle from your list. So 1's have in common. This one only has a 2. This one doesn't. 3 and 3. 4 only in this one. 5 only in this one. So we only circle the ones that they both have in their list. So 1 and 3 are the only common factors that we have. Then what's the greatest common factor? Okay, sometimes we call that the GCF. Okay, in this case, greatest does not mean like most awesome, but it just means the biggest. So what's the biggest number that we put in our list of common factors? Well, it was 3. So 3 is our greatest common factor, or our GCF. Okay, so I gave you guys a chance to work on one. We did 16 and 20. This was the list that we came up with for 16, and this is the list we came up with for 20. And then notice we circled 1, 2, and 4 because they had them in common. And then what's the greatest of these? Well, 4. 4 is. All right, so it would be our GCF, or our greatest common factor. Okay, then we went back into the book, and this was, I believe, page 42. And it talked about prime factorization. Remember, prime factorization lists each number only with prime numbers. So 56 and 42 is 2 times 2 times 2 times 7. Notice there's no 1s here, and there's no other numbers in this list that could be broken down further. All right, so for example, 12, I can split it into 6 times 2, and then 6 I can split to 3 times 2, and then notice I like bringing down this 2. They don't. But I like it, because then at the end you have your prime factorization. Just usually put it in order from least to greatest. So 2 times 2 times 3. And that's our prime factorization. And we kind of jumped ahead, so I'm going to skip a few pages to get to multiples. Multiples are basically when you count by a number. All right? They're the result of multiplication. So factors are the building blocks. Multiples are what you get when you multiply, the building, so to speak. So we just counted by 8s, 8, 16, 24, 32, 40, and so on. And then 6, 12, 18, 24, 30, 36, 42. And we circled which ones they had in common. They had 48 in common, and they had 24 in common. Okay, and then we took a look at the least common multiple, because they both have 48 in common. What's the smallest multiple they have in common? Well, 24 is. Okay, so here we had you look for the LCM of 6 and 9. So we counted by 6s all the way from 6 to 54. Then you counted by 9s all the way from 9 to 54. And then we circled the ones they had in common, 54, 36, and 18. And asked, what's the smallest common multiple of 6 and 9? Well, 18 would be. All right, so the LCM would be 18. All right, then for your assignment, I wanted you to do questions 1, A through D, questions 2, A and B, and 3, A, B, and C. And look here, it says list all the factors. Now notice it doesn't say list the factor pairs, so be very careful of that. We just want to list, so you'd start listing all the factors of 18, listing all the factors of 30. Very similar to that slide earlier. It's basically the same kind of questions. And what's the greatest common factor? All right, and then consider the numbers 54 and 72. We're going to have you do the prime factorization of these two numbers. So don't list all the factors, just do the prime factorization, okay, the factoring trees. Then here, multiples, find the least common multiples. So find the multiples of 3, multiples of 5, find the first one that overlaps, or in other words, they both have in common. And then 4 and 6, and 8 and 12. All right, so hopefully this video was helpful in reviewing what we were talking about. Feel free to watch as many times as you need to help LCMs and GCFs make sense.